Next we have Christopher Morrone and Giuseppe is it Natale or Natale? Di Natale. They're both from Lawrence Livermore National Laboratory. Christopher Morrone, he's the file system software team lead at Lawrence Livermore National Laboratory. He began working on Lustre 14 years ago. He's also my favorite cue ball. Giuseppe's a computer scientist at Lawrence Livermore National Laboratory. He helps maintain and support Lustre within the Livermore Computing Center. Hats off to me for not confusing you guys with Los Alamos like last year. That was tough. Improve versioning, building, packaging, and distributing of Lustre. Take it away.
So downloading and installing Lustre can be more difficult than we would like. That is still the old slide. Thank you.
Sorry, man.
Still going, still going. OK, there we are. So installing Lustre can be more difficult than we like. If you're a new user to Lustre, you find out you need to download a whole lot of packages, and not only do you have to download Lustre and some of its dependencies, you might have to replace your vendor-provided kernel with one that Lustre provides. Not everyone wants to do that. And if you want to use your own kernel, patch it yourself, you're going to have to build Lustre yourself. And you may find that building Lustre is a challenge. So we're going to talk about just some ways we're going to make the process a little better. But first, I'm going to start out pointing out what the version string in one of the RPMs looks like right now. And bear with me as I read it aloud. We've got Lustre-2.8.0, 3.10.0 underscore 327.3.1.el7 underscore Lustre again, in case you forgot, because it has been a while, .x8664, .x8664 again, .rpm. And I joke, but there are actually reasons why all of this appears in the package name. RPM packages have a lot of metadata contained within them, and some of those metadata fields appear in the version string, in the name of the file. So first of all, obviously we have the name of the package at the beginning. Next we have the version, which is the main version of Lustre as the RPM knows it. Next we have a release field, which is this giant string here. And some of you already know that's actually a copy of the Linux kernel's version string. That's why we have Lustre in it again, because this version of Lustre was built against a patched kernel, a kernel that was patched by Lustre patches. And that's why we have two x86-64s. One of them comes from the kernel string, and one of them is the architecture of the Lustre package. So while there are reasons, we can still do better. There are some problems here. So first of all, we're abusing the RPM release field. The release field is really supposed to be just for the packagers, not for including major information about Lustre itself. As we'll see in a moment, the tarballs are versioned incorrectly right now. The way we build and distribute Lustre, we're tied to a specific build of a kernel, which can be a problem for a lot of sites where you want to be able to upgrade your kernel whenever you want. You can't build Lustre without having a full Git checked out working directory, and that can be frustrating at times. Usually that's okay, but there's times where that gets in the way. It's incompatible with Koji. If you haven't heard of Koji, it's the build system that Fedora and Red Hat and EPO, a lot of the major distributions, use that to build packages for the entire distribution. Lawrence Livermore, we roll our own customized version of RHEL, and we're moving to using Koji. Unfortunately, Lustre doesn't build through Koji. There's some problems with the release candidates that we've been doing in the past. I'll get to that in a moment. And internal to the code, if you're a developer, it's very confusing right now how there's multiple header files that contain different versions of Lustre, and figuring out the multiple paths in which it can be generated is rather confusing. Here's some more examples. So you all know the major version numbers that we put up here all the time, 2.8.0. There's a lot more versions that can go on behind the scenes. during development, if you're a Lustre developer or a Lustre tester, you may have builds of any random commit of Lustre that you want to test that's beyond one of the recent Lustre tags. So you're going to have this extra field at the end here, which is essentially a little bit of the git hash. And that uniquely identifies where this code was built from. Unfortunately, we got the Lustre version here, and then we got more Lustre version over here at the end, hiding after the kernel string. And if you're a third party, like Livermore, or you're a vendor, and you're doing your own custom versions of Lustre, where you have your own patches that you're carrying, you want to somehow uniquely identify your releases. You don't want to have everyone putting out 2.8.1 and 2.8.2. Whose 2.8.2 is it? Which code are you running? So you're going to want to have an extra little string in there to say, if you're a company named Acme, this is the 9 Acme release after Lustre 2.8. And then you might have both of them. So you've got the Lustre version, the upstream tag, then you got the third-party tag, and then over here at the end, you've got the development version. And they're all spread out. One's in the version field, these two are in the release field at other ends of it. It can make things a little difficult. So here's another problem. These 3 packages, all files were built using the same commands. So this is a development version of Lustre, and it has a third-party tag on it. When you build the tarball, it doesn't have any of that information. It just says Lustre 2.8. The source RPM that comes out, well, it has the development information, but there's no third-party information. Then the binary version, it's got all 3. The problem with them not matching is a lot of standard tools like Koji want the release field and the version field to be consistent throughout the process. So it sees these come out and they don't match, it goes, sorry, can't build that package. That's not going in the distribution. Wait, did I miss one? Nope, that's good. So things are getting better though. On the master branch, I have a patch that just went in, and now things start to look a little better. Now when you build a tarball, it's going to have the full information in it. So the tarball itself is uniquely versioned. If you want to go back later and go, what was in that tarball, you'll know where it came from, and it'll match the other files. The release field now is left alone, at least in the source RPM. We're no longer trying to take that over in Lustre. And then the binary RPM, it's mostly matching, but we still have that kernel string in there. That's still going to be a problem for Koji and for some other things. If you're interested, you can go look at the commit that made this cleaner. So one thing to know, if you're a third party, if you're a vendor, if you're a group like us that builds your own versions of Lustre and adds your own tag, you may have been using in the past the -- with downstream release option of the configure command. That is gone. We're no longer doing it that way because that stuck the version in the release field. We want that version to be part of Lustre's version string. So now there's documentation inside the tree. You can go read up on how you should be doing your versioning here. A short summary, though, is now there's a script at the top level of the tree called Lustre version gen. At the top, there's a default version string. You want to set that, do a commit, and then you want to make a well-formed tag, which the documentation will explain how to do. If you have any questions, you can open a ticket or comment on the mailing list, and we'll help explain more about it. So another problem with how we've been doing things lately is the old code used to have a special case for release candidate tags. So every time a release candidate comes out, we build packages, but you'll notice that the packages don't contain the release candidate numbers. So every single release candidate, 1, 2, 3, 4, 5, they all have exactly the same version package names. Well, because of that, we didn't actually distribute any release candidates because we can't have 5 different versions of code all with exactly the same version. But of course, it is an open source project. When we do release candidates, we really want to put packages out there. We want people to test them. So the new code I have does not support this special casing of release candidates. We're going to have to come up with a new version, new way of doing release candidates numbers. So the packages are uniquely versioned. We can tell people about them, put them out there, and get some help testing things. So the next step, we want to be fully consistent. From the tarball to source RPM to binary RPM, we want all the versions to match. You'll notice in the future, no kernel version release string. The versions kind of long here, but this is a third-party version and it's a development tag. For normal community releases, they're going to be even simpler. It'll just look a lot like that. The release field we leave alone. It'll always be 1 unless you need to do some packaging changes. The version will be fully contained in the version field. But in order to do this, to get rid of the kernel string, we need to complete a particular ticket, LU 5614. So the problem we have right now is that we are patching the kernel, and the way we package Lustre, every time you change the kernel, you have to rebuild Lustre. For Linux version A, you've got to have a Lustre version x.a. For version B, you've got to have a Lustre version x.b. It doesn't matter that the Lustre code hasn't actually changed. If the kernel changes, you have to rebuild Lustre every time. And to make it easier on people to be able to tell these packages apart that have the same Lustre version, but only work with a single kernel, we stick the kernel string in the release field. It just makes it a little easier on sysadmins and people using the packages to figure out what matches up with what. But it turns out we don't really have to do this. We haven't had to in quite a long time. A lot of the Linux distributions have something called weak updates, weak modules. And the neat thing is that when a new kernel is installed, the scripts on the system will automatically figure out whether your kernel modules are binary compatible with the new kernel. If they are, it links all your modules into that kernel's directory. So in the future, you can keep updating your Linux kernel, and you don't have to update Lustre each time. You can do them independently. And that lets us partly get rid of the kernel version string. There's one more thing that lets us get rid of that. There has been one problem with this. This patch has been underway for 18 months. Stephen Champion from SGI originally did this, did a lot of work on it. Then Alexander Boyko from Seagate, he stepped in, did a bunch of work. I've been doing a lot of reviews and testing on this. More recently, Min from Intel's been involved. And it has gone through a lot of versions, 20-some versions, but I don't think the problem really is the patch itself that's taken 18 months. The problem is getting the code through the Intel build farm is extremely difficult because Intel build farm builds packages in a way that no one else in the world builds packages. So we can build this under CentOS, we can build under Koji, works everywhere but at the Intel build farm. And we don't really have enough control over the Intel build farm outside of Intel to make the changes in a timely manner to get this done. But recently, Intel has put Min on it, and I'm very hopeful that in time for Lustre 2.9, we'll have this done and have it landed. So another problem to be able to let us get rid of the kernel version string in the packages is that we're patching the kernel. So you may have heard the term patchless in a lot of different contexts. So in the current context, Lustre has some patches that we apply to the Linux kernel and do our own kernel builds of Linux. There are also patches that Lustre combines with the ext4 code from the Linux kernel and turns them into LDiskFS. When we talk about going patchless, we're only talking about getting rid of these patches on the left, the patches that modify the Linux kernel. You'll still need patches to turn ext4 into LDiskFS. But once we get rid of these, and this work's been underway since LU20, and so that was the 20th bug in Jira. We've been using Jira for years now. It's around 2009 that project really started. Most of the patches are gone, and technically you can't even build LDiskFS without patching your kernel right now. We're still patching the kernel and distributing patch kernels because during testing, we need one particular patch to be able to do LDiskFS testing. But in LU684, there's work underway to replace that. And once that's gone, then we can finally get rid of the kernel version string from the RPM packages, and we can finally be able to build Lustre through tools like Koji. Now, because we've had so many problems with getting the weak updates code landed, and because things have changed over time, the Intel build farm was built in the days where we didn't have VMs, weren't nearly as mature as they are today. We had to patch the kernel. We had to build a lot of different things. Today, we can pretty much, once a couple more things are landed, we can just build Lustre by itself. We think it's probably a good time now to have a new build farm because a lot of the assumptions the old build farm was built under no longer apply, and it'd be a little too difficult to just incrementally change that build farm. So at Livermore, we've started the work to actually stand up a new build farm in the public that will be available to the entire community to control and modify. And I'm going to turn it over to Giuseppe to tell you about that work.
Thank you, Chris. So as Chris mentioned, I'm going to go ahead and talk about a build farm I started working on that, as Chris mentioned, is going to be open source to the community. So first we'll start with some goals. So similar to the Intel build farm, for every commit in Garrett, we want to go ahead and spin off a process of building on various distributions and architectures, just to verify that whatever code submitted could still be distributed to a wide array of platforms. We want to publish these build results and produce them in a timely fashion for rapid development, because developers need feedback quickly. We've seen cases where the Intel build farm might stall for about a day before you get any results. So we want to improve on that. And we also want to eventually test functionality and, again, publish those results. At the beginning, it might just be exactly the same test that Intel's running, but as a community, we hope to widen that a bit and introduce different layouts, different server structure, and such. And as I've already alluded, we want a community-driven environment. So if there's a new need that pops up, the community could step up and go ahead and add things or suggest things if they don't have the cycles to introduce it themselves. So this is when the OpenSFS build farm was created. It's built and backed by BuildBot. I'll get more into that in a second. The configuration is actually on GitHub at the moment under the OpenSFS organization. I'll have a link at the end of the presentation. And it's hosted right now on Amazon Web Services. And the reason for this is we want scalability. And we didn't want to maintain hardware. So AWS is actually perfect for this, especially with spot instances and things like that. It's cheap, and the hardware maintenance problem's gone. So why did we choose BuildBot? Well, it's flexible and extendable for a number of reasons. It's open source, code's out there, community's active doing bug fixes, and we've been finding bugs, and we plan on releasing those upstream as well. There's good interoperability with other tools. There's functionality for Git, Garrett, and such. It's a developer-defined workflow, so it's a little more complex than just having a GUI and then putting these steps in, and then the build system decides what to do. So it could be as simple or as complex as you want. And as a general rule, if you could script it, BuildBot, chances are it could do it. So that was handy. It's very general purpose. So BuildBot also has out-of-the-box support for Garrett and EC2, which was perfect for our needs. It already hosts a web page for people to read up on what builds are in progress, what the status of the builds were, did they succeed or fail, and to collect output. As you may know, Brian Bellendorf works at Lawrence Livermore. He has already produced a BuildBot instance for ZFS, so we were building on his experience, and we've been in close collaboration to try and get fixes and such. So I just want to give an overview of the BuildBot architecture. So that middle box, right there, the Lustre Build Master, it's the central hub for everything. BuildBot has this concept of builders, which is basically a collection of slaves. So I've included 2. And there's also factories that the master maintains, which is basically a script of steps that a slave might run once it's assigned a build. So a build will come in, the master will assign it to its builders, and the builder will choose a slave and then start issuing commands, which are these blue arrows. So the master will issue commands to these slaves. They'll run through the process, and later on the master will collect the results from that build and publish it on the portal. So I'm going to go ahead and show you a couple of screens from the portal. So this is the waterfall view. So across the top, up there, and with the green and red, those are the builders. Below that, the yellow boxes, there's pending builds, things in progress, so it's going to give you an estimate of time till completion and how many are pending. Along the left here, you see changes. In fact, there's one of James' changes right there. You'll get to see a running timeline of when changes got submitted. And in the middle area, these are all the different builds that are going on under each individual builder. There could be multiple builds depending on the number of slaves. And it just gives you a step-by-step of what's in progress and what's been completed. And it does get noisy, so there is another view that will help. It's called the console view. And so this is more on a commit-by-commit, a commit-based list, I'm sorry. And so this gives you a readout. Basically, these bars represent your different builders, and these little boxes show you the status on that builder. Did it succeed? Is it in progress? Did it fail? So on and so forth. So you could get a more individual status for each commit. So what do we currently have in terms of builders? We're currently building patch sets on a variety of distributions, CentOS 6.7 and 7.2, both of which are being compiled against ZFS and LDiskFS. We're also doing SUSE 12.1, backed by ZFS, and two different flavors of Ubuntu 12.04 and 14.04, backed by ZFS. And we're going to soon have a PowerPC builder, since AWS only supports x86 64. So Chris is actually going to provide a PowerPC slave that we could use in order to add some variety to our architecture list. And we would appeal to you as a community to provide slaves. You could stand up hardware, and we could incorporate it into our build farm to get a little more variety. So I just want to make a quick comment on build turnaround. For a single build, worst case is 40 minutes. Slaves have to spin up and boot. If they've been idle for too long, they shut down. Best case is 15 minutes if slaves are already idle. And I'm speaking just as a single build. There's a few outstanding issues. Multiple Garrett commits that come in all at once. Bursty traffic causes problems. So we're looking on how to alleviate that slowdown. Slave startup can be improved, and there's a number of techniques to do this. I won't really get into that. But there's going to be work to improve that. And there's a architecture BuildBot makes slave startup sequential, and it's very slow. So there's a lot of delay. When things could be happening in parallel, it benefits everyone. So we have some future plans. We currently don't publish build products, but we are going to work towards that. We want to get the community involved in testing, so we'll publish RPMs and such once some of Chris's changes land as well. So if you have a specific feature you want to test before it's out there, you could. We want to supply build status on Garrett, so you get that feedback and it's all in one place. We want to automate some testing. And we want to build eventually the official packages for all the tags that come out. And we really want some community development and maintenance. It'll be a group effort, basically. And we strongly encourage that. So in summary, what Chris talked about was versioning and packaging, the consistent versions, the Lustre builds through standard tools such as Koji, the weak updates, and changing the third-party versions. The Lustre BuildBot, you could email us at the email there. It's already up at build.lustre.org if you want to take a look. It's been building for weeks, Garrett changes that have been coming out. Repository and issue tracker is on GitHub and the configurations there. We also have our own version of BuildBot, which you could take a look at. And we hope it becomes community driven and it's hosted on AWS. And with that, any questions, comments, ideas, and please get involved. I'm sorry?
Are you building a kernel?
We are, he asked if we're building the kernel. We are not currently building the kernel. We want to focus on just building Lustre in the Lustre build farm.
Right.
Okay, thank you.
I have a quick question. How do you deal with third-party interconnects like InfiniBand, because AWS doesn't have?
Currently, we don't have a plan for that.
Did you scan a Lustre source code to avoid to use any symbols except of whitelist? Because we have tried to use a weak modulus options and find an issues when the entry cache flags was changed between Red Hat kernel versions, and it produced problems with mounting Lustre client built for one kernel after upgrade.
Well, it's going to depend on your kernel and your vendor. RHEL is pretty good about keeping the ABI consistent within major versions of RHEL. So within RHEL 6, you're likely to be able to keep using the same version of Lustre, even through multiple kernel upgrades. And this time around, we're not hacking in weak modules. We're using the official macros provided by the various distributions to generate the weak modules support. So I think it's going to be a little more consistent and usable than it was in the past.
Probably we need to open new task to scan a Lustre code to avoid use any unstable IPs, which may be blocked to use a weak modulus in build farm.
That could be, and we can totally in the build farm add additional checks to avoid unstable test experimental symbols.
Yeah, I would love to see the build environment managed as a Docker container, so it's easily reproducible in any environment and identically reproducible every time. Also, it makes sense in a build farm to run the builds inside an isolated environment like a container, just so that you always refresh the environment every time you do a build.
So if you've taken out the kernel, all of the kernel information, how do you know whether your package is for EL6 or EL7 or SLES12 or whatever, right? There's no identification of which version. And I mean, maybe that's okay for user tools, but obviously for all the kernel module, that's not okay.
Yeah, we're going to have to figure out, I think largely that's going to be solved by the directory structure that we put the eventual packages into. Well, when you go to the HTTP or FTP server, there'll be a directory called EL6 or EL7, and that'll be the major way that you'll find out which packages will work for your platform.
I thought like separately packaged kernel modules typically have the kernel version in the name.
There are various versions of KMod. And there are, if you weren't building with weak modules, if you were building against a specific kernel, then yes, it would have the kernel string in it. And usually they wind up putting the kernel string in the package name, actually, because then you can actually install multiple versions of the same package because you're allowed to install multiple kernels. But since we're using weak updates, you don't want the kernel string in there. You want it to be able to apply against multiple kernels.
Not even a high-level name like EL6 or EL7, like any regular package that gets built has a vendor string in it like that.
Yeah, in the release field, I believe at the end there will probably be like an EL6 or EL7, and yeah.
So I was just curious, is if we provide a slave and if it has InfiniBand, OPA, or anything, is that a workaround for not having the infrastructure to have different kind of networking and still be able to provide that build generated for us? But would that be usable for any other purposes?
That's certainly possible. And technically, you don't actually need InfiniBand hardware to be able to compile. You just need the packages installed. So there's really no reason we couldn't even stand up additional builders in the future where they have the InfiniBand packages pre-installed. You could have one with InfiniBand package in. It could be Docker managed. It could be some other way we're generating stable AMI images for every configuration. It's totally doable.
So if there are some patches that are coming out in the community version or can I request that to be included in the build process, or is that something that you would?
So the way in the community we work, if you have a patch against Lustre, you push it to the Garrett review system. Every single patch that goes through the Garrett review system is going to trigger a build on all the platforms in our build farm, kind of like it triggers a build in the current build farm. We hope that ours will give faster turnaround. It can take like 3 hours, 6 hours, 48 hours before you find out if your package built on the current one. We're hoping, if we have enough money to keep all of them running in parallel, that you'll know at least if your package is built within 15 minutes. That's my goal for it. Testing will take much longer because testing takes longer.
So how does this work with the Intel edition of Lustre? Will it work for any version of the builds that come out with Intel edition?
We still have to work that out. We don't know what our collaboration is going to be with Intel. This is the first time we're presenting it publicly and announcing it. So we'll have to see how it pans out. We hope that Intel will be one of the community partners and work together with us on it.
Okay, so thanks. Airing of grievances. I mean, were you thinking Festivus?
I was.
Yeah, I figured. Right. I don't know. Thank you.